Hello everyone, welcome to etutorpool.com. In this video, we will continue our discussion on limits. At first, let me do a quick summary of the previous video. We have discussed that limits are all about approaching. We saw that with the help of one function, fx equal to x square minus 1 upon x minus 1. At x equal to 1, when you substitute x equal to 1 in this function, you will get 0 by 0, an indeterminate form, which are always difficult to evaluate. So we have used approaching from left hand side and from right hand side. When we have approached from the right hand side, we got 2. When we have approached from the left hand side, we got 2. So at x equal to 1, the limiting value of the function is 2. So we can say that at x equal to 1, limiting value of the function exists. Okay, now let's start our discussion. What if we get different limiting value of the function at a finite point? What I mean to say that when you approach from the right hand side, you are getting some value, and when you approach from the left hand side, you are getting some other value. Both values are different. So whenever this type of case occurs, we can say that at that point the limit does not exist. Let's understand this with the help of one graph. So how about a function fx with a break in it like this? I have already drawn the graph of the function. Now here, when you approach from the left hand side, when you approach from the left hand side, when you approach from the left hand side, you are getting 2. And when you approach from the right hand side, when you approach from the right hand side, you are getting value 1. So we can see that 1 or 2 are not equal to each other. So limiting value when you approach from the left is not equal to when you approach from the right. So we can say that at x equal to a, the limiting value of the function does not exist. Okay. So we saw one case where the limiting value exists. We saw this case where the limiting value does not exist. All right. So uh, limits are not only for difficult functions. All right. So limits are not only for difficult function. Limits can be used for every function. For the, as you can see, this is a very simple function. Fx is equal to x minus 5. When you approach from the left hand side, you are getting 1. When you approach from the right hand side, you are getting 1. Because you are not getting any indeterminate form here. I have already drawn a graph of the function here. This is a simple straight line, y equal to x minus 5. When you approach from the left, you are getting 1. When you approach from the right, you are getting value 1. So at this point, limiting value exists, and which is equal to 1. All right. Now, let's talk about approaching to infinity. Okay. So at first, let me talk about little bit about infinity. So we already know that infinity is not a number, it's an idea. Okay, maybe we could say that 1 upon infinity is equal to 0. But there is a problem, because when you divide 1 into infinity pieces, they all end up 0. and when you add 0 0 you won't be able to get 1. So what happened to 1? So we already know that ki, ki, we already know that 1 upon infinity is known to be undefined. Okay, we already know that 1 upon infinity is known to be undefined. Okay, so now let's try approaching. Okay, we have substitute the direct value infinity, but it is undefined. Now let's try to approach it. Okay, suppose if this is a function fx is equal to 1 upon x. Okay, as x approaches to infinity, this will be 1 upon infinity, and we want to find out what happened to this value when x approaches to infinity. Okay, so when you substitute x equal to 1, 1 upon 1 1, when you substitute x equal to 1 upon 2, you will get 0 0.5. When you substitute 3, 1 upon 3, this will be 0 0.3333. So as you increase this value, when you substitute 1000, 1 upon 1000, you will get 0 0.0000. As you can see that this value is keeps decreasing. As you as you increase the value of x, the value of fx is keeps decreasing from 1 to towards 0. Now we can see that as x gets larger, 1 upon x to, tends towards 0. Same as before, we have faced an interesting situation here. So, what is the interesting situation here? We cannot say what happens when x gets to infinity because it is undefined. What we can see that 1 upon x is going towards 0. So, the limit of 1 upon x, the limit of 1 upon x as x approaches infinity is 0. The limit of 1 upon x as x approaches infinity is 0. So in mathematical form you can write this way: limiting value, this is a limiting value as x approaches to infinity, 1 upon x, this is 0. Okay, so always remember limits are all about approaching. Okay, now now we are going to understand more this with the help of one example. Suppose you have a function x upon x square minus 1, and you want to find out the limiting value of this function as x approaches to infinity. X approaches to x is a very very large number. Okay, we don't know what would be the value of this function, so let's make a table which I have already made here. Suppose when you substitute x equal to 1, you will get 0 0.5. When you substitute 2, you will get 0 0.2. When you substitute 1000, you are getting this value 0 0.00099. When you substitute 10,000 x equal to, you are getting 0 0.00009. As you can see that when you are increasing the value of x, the value of fx are keep decreasing. So we can see that as x gets larger, x upon x square plus 1 tends towards 0. So we can say that the limiting value of this function as x approaches to infinity is 0. All right. I hope you understand uh, this approaching infinity, and where the limiting value does not exist. All right. Thank you.